bartender.
What'll it be?
I'll have a bourbon. Straight up.
Sure. Looks like you had a tough night.
I got troubles. You could say. Well, troubles.
Troubles? Really?
Yeah. This arrogant guy in my statistics class. Well, he said I made a mistake on my examination without even looking at my work. Can you believe that?
Was he right?
That's the really annoying part. He was. He was right. Just because I calculated a z-score of 100.82. He said I made a mistake. Like he just knew for sure. See?
What's your name?
Skeeter.
Well, Skeeter, that is a pretty extreme z-score. Could you even find it on the normal distribution table?
Oh no. Not that again. It's extreme. I know. It's not on the table. I know.
Ha ha ha. I'm sorry.
What's so funny?
No. It's just...
What?
Was it a hypothesis testing problem?
Well, why yes. It was indeed.
I was laughing because you can actually make the z-score to be as large as you want. As long as, well, with a large enough sample size, you would have a really small standard error of the mean. Do you know what the standard error of the mean is?
Sigma over the square root of n.
That's right. So do you know why a large sample size makes the standard error of the mean small?
Indeed I do. Dividing by a large number makes a whole fraction. That is, sigma over the square root of n. Small. So, large sample size. Small standard error of the mean. So as long as the numerator of the z-score is not exactly 0, a small standard error will make the z-score big. Oh. So you're saying
it didn't have to be a mistake. It could have been correct. But, well, was the sample size large?
No. It wasn't that large. But, how large would it have to have been for my answer to have been right, and for Slick Matthews to have been wrong?
Let us now re-examine Skeeter's work. Let us keep the difference between the sample and hypothesized means the same, and let us solve for the sample size that would make Skeeter's huge z-score correct. Then, we will draw an important general conclusion about large sample sizes.
So I met this really cool guy in my statistics class today at the Math Learning Center. So, really? What is his name? Skeeter. I know him. He calculated his z-score on our examination and didn't follow the order of operations.
You mean please excuse my dear Aunt Sally?
Yeah. He didn't know to put the parentheses into the calculator. I showed him.
Could you show me? I mean, well, I would like to know how to do it on the calculator too.
Sure. Let's first look at the formula and then the keystrokes.
We use this formula to calculate a z-score for the sample mean distribution. These are the values Skeeter and Slick used to calculate the z-score. Substituting these values into the formula, here is Skeeter's incorrect calculation. Notice how Skeeter entered the formula into the calculator. We should understand that parentheses are implied in the numerator and denominator of a fraction. We must type them in when entering the formula into a calculator. Here is Slick's correct calculation. Slick knew to include parentheses in his calculation. Slick obtained a reasonable value for his z-score.
Hello, and welcome to College News. I'm Roger Clemens. We are here at Suffolk County Community College where we have just learned of some late-breaking news. Apparently, a student, named Skeeter Pearson, calculated a z-score without following the order of operations. His classmate, a Mr. Slick Matthews, discovered his mistake by realizing that his z-score was so extreme as to warrant a second look. The discussion motivated Skeeter to check his work at the Math Learning Center where his mistake was ultimately revealed. When asked about it, he told College News that he was sad about his mistake, but now knows to always check his calculations if he observes a z-score of more than 4 or 5 in absolute value. He added that he is confident about the final examination. This is Roger Clemens, reporting for College News.